A PDF of a continuous distribution is shown below. We want to find first the value of A. We can see that this is a triangle and we know that the total area in here has to be 1. We can see the base of the triangle is 6. So a half times 6 times the height has to be equal to 1. And of course the height was A. So that gives me 3A equals 1. And that tells me that A is 1/3. So we now want to find the PDF. We know that the height here is 1/3. And this is 3, which means the gradient here is going to be 1/3 divided by 3. So it's going to be 1/9. So we can say that the equation of that line is y is 1/9 x plus some constant. But it goes through 1, 0. So 0 is equal to 1/9 plus a constant. And so the constant is negative 1/9. So this section here has equation y is equal to 1/9 x take away 1/9. And we'll use that as part of the CDF in a moment. We now need to look at the other section. Well, this is 3 across as well, but of course the gradient is negative there. So we can say that that one is y equals negative 1/9 x plus a constant. It goes through 7, 0. So 0 is negative 7/9 plus a constant. The constant is 7/9, and therefore that section is y is negative 1/9 x plus 7/9. So we're now in a position to state the PDF. So for part B, our PDF is going to be 1/9 x take away 1/9, which applies when x is between 1 and 4, negative 1/9 x plus 7/9, which applies when x is between 4 and 7. Note that I've used just here, you can see that I've used less than or equal to, so therefore I don't use that again there. I just say less than. I could have used the less than or equal to here and the less than here. And of course, we've got 0 otherwise. So now for part C. And in C1, we want to work out the property that x is less than 5. So we know that the area we want is going to be this area add this area. And because of the symmetry of this, we can tell the area here is 0.5 or a half. So that's going to be a half. Now, obviously, this is a geometric shape as well. It's a trapezium. But we've got the function. We could do it as an integral. So we'll do the integral from 4 to 5 of negative 1/9 x plus 7/9. And you can see on the calculator here, I've already done that integral. I know that we could do this integral manually, but let's take the sting out of it, use the calculator to save time. And so what we need is a half, add that last answer, and that gives us 7/9. Now the next part of the question is a conditional probability. We want the probability that x is less than 3, given that x is between 2 and 5. Now remember, the probability of A given B is equal to the probability of A and B divided by the probability of B. So that's both conditions here at the top. So both conditions, and on the bottom just the second condition being met. So if we have to be between 2 and 5 and less than 3, that means it's between 2 and 3. So that's going to be the probability of x being between 2 and 3 divided by the probability that x is between 2 and 5. Now between 2 and 3 means that's all happening within this part of the PDF. So we could do that as the integral from 2 to 3 of 1/9 x take away 1/9. But then we need to divide that by, if we're going from 2 to 5, 2 to 4 is within this first one, but 4 to 5 is in this second one. And in fact, we already had the answer to that on the calculator. Let's just make a note. That was 5/18. And so we would have the integral here from 2 to 4 of 1/9 x take away 1/9 dx plus 5/18. And I've just done that on the calculator, and we can see that that comes to 3/13. Finally, in part D, we want to find the CDF. So let's just think in this first section, we have some value x. So we're going to do the integral from 1 to x of the first part of the PDF. So we'll do that as 1/9 t, just use a different variable. Take away 1/9 dt. And once again, I've already done that on the class pad. So it gives me x squared over 18. Take away x over 9 plus 1/18. Now that should be 0 when x is 1, because of course the distribution starts here at 1. And indeed that would be 1/18, add 1/18, take away a 9th, which is 0. It should also be a half at 4 for this symmetric distribution. So let's just check that. So if I just bring that down there and say given x equals 4, it is indeed 1/2. So that works perfectly well as the first part of our CDF. Now, in the second part, so this is no longer x, so if x is now up here, we already have this area, and then we want to add this area on. So that should be 1/2 plus the integral from 4 to x of -1/9 t plus 7/9 dt. And let's see what that gives us. So once again, I've done that on the class pad. You can see that here. And it gives me -x² over 18 plus 7x over 9, take away 31 over 18. And to make sure that works, we know it should be 1/2 here and 1 when we get to there. It's always worth checking these things. So given that x equals 4, that would be 1/2. And given x equals 7, it's 1. So that seems to work perfectly well. And that means that we can state our CDF. So f of x is going to be, well, it will be 0 when x is less than 1. Then it's going to be x² over 18, take away x over 9 plus 1 over 18 for x between 1 and 4. And then it will be -x² over 18 plus 7x over 9, take away 31 over 18 when x is from 4 up to 7, and then 1 if x is more than 7.